Scientific and technological developments are based on the facts and the data gathered. The facts are realized along with the supporting data records through the process of careful observations, which enables them to develop and then test hypotheses and theories. They use different tools for that, such as questioning, predictions, logical consequences, testing with controlled in nature experiments, and the field experimentations. These observations are useful in all the fields of science and technology such as medical sciences, biomedical engineering, molecular biology, mechanical engineering, microfluidics, surveillance for administration, security and defense applications, robotics and drone through surveillance applications, etc.
For example, digital movie cameras are nowadays replacing old days film cameras, although both have their pros and cons. They are in two types, mainly the prosumer-consumer cameras used by independent low-cost movie makers, and the professional cameras used with better quality of optics, sensor size, frame rates, lens integration, and the resolution or the definition. They use either standard definition or the high definition in a progressive scanning. Video with less than 480 vertical scan lines in America and less than 576 lines in Europe is generally termed as standard definition video. Beyond is the high definition video. The progressive scanning or scanning based on odd and even lines in an alternate sequence causes only half the number of actual image frames available to produce a video at 24 frames per second. Our imaging solution by Omnilert Systems Engineering Private Limited crosses these limitations, and here we are to give this industry an imaging solution at much higher speed at high resolution.
People use a combination of different optics and cameras or the camera sensors depending upon the field of application or research. Single shots are used for capturing the still objects, and the series of images are captured for objects in motion. During multiphase flow analysis, high-speed droplet particles of size 50 to 100 micrometers can be captured by high-speed cameras rather than still imaging cameras. As the speed of the objects go on increasing, the frame rate of cameras, which is also called as camera speed, must be high, otherwise it causes a motion blur. It is not a blurred image, but it is an image with a motion blur associated with particles, while a background is not having any blur. Blurred particle images make the particle characterization difficult. A way to tackle this is to increase the speed of the camera. However, with the increase in the frame rate, the resolution goes down and the frame occupies lesser volume of the particulate fluid. With the further increase in the imaging speed, it may not be possible to occupy even a single droplet particle of 100 micron size in a single frame. Increase in frame rate of camera sensor causes low lighting condition, where light coming from particles or objects falling onto the camera sensor is low and thus affects the visibility of the particles. Through the characterization, one may find particle velocity, acceleration, size, flux, density, vector mapping, scalar mapping, oscillations, etc. We at Omnilert Systems Engineering provide a series of imaging systems and cameras that overcome the aforementioned problem to a great extent for the image sensors designed for very high frame rates. This is quite obvious if one goes through our camera manual present on our displayed website. A pixel read time is the time required to digitize a single pixel. Readout rates are usually given in pixels per second. All the pixels create one image in a duration that is equal to a readout time of all the pixels. First, there is acquisition of an image and complete reading out of that image. Frame rate is typically expressed in frames per second. The frame rate can be approximately calculated from the total number of pixels and the readout rate, combined with the total exposure time. So, the approximate frame rate can be calculated from a product between number of pixels and time to read one pixel and the total exposure time. So the total time for one frame is the sum of frame reading time and frame acquisition time. As the sensor size increases, the time required for each image frame is more. This causes reduction in total frame rate in serial imaging. With high resolution of the image, bigger the sensor size, better is the result with the imaging technique developed by us. During the imaging, once the data is gathered onto the onboard memory of the acquisition device, the need is to transfer it at a high speed into the PC memory. Direct real-time measurements and transfer of data from acquisition terminals into a computer in a real-time mode is impossible at a high speed of around 250 Mbps and more. This was due to the limitations of data carrying capacity of carriers such as the USB cables. It is noteworthy that the signals and data generated at sensors can be carried from sensors very fast using BNC cables onto the onboard DAQ memory. However, carrying the data from onboard memory of the DAQ card to the PC was a long-lasting process. A need was felt to improve the data transfer speed and the means to do it. A 64-bit systems can handle and process more data at once than the 8-bit, 16-bit and 32-bit systems. The number of binary digits goes on increasing with the increase in the bit value. A 64-bit computing, data acquisition and processing device is said to have more resolution and have larger access to the memory address locations. This high-resolution data is transferred over a time domain or SPS domain of a frequency domain in terms of SPS. The time required to transfer the data is high though the resolution is high. We have developed our own method to transfer the entire high-resolution data using an 8-bit system. This can be accomplished by first using a single frequency generation, then the slicing of the same single frequency with the help of clock signal that carries the data upon it, and then the storage of frequency value, in binary form only once, in the 8-bit clock data into the memory. The frequency value corresponds to or remains analogous to the resolution level, whereas the 8-bit clock data is the data information. For 8-bit systems, 60 Hz can be sliced. For 16-bit systems, 70 Hz can be sliced. For 32-bit systems, 80 Hz can be sliced, and so on. Here the frequency is the indicative of resolution level, whereas the entire data information remains in 8-bit.
We, at Omnilert Systems Engineering Private Limited, give the fastest imaging solutions and products for several areas of scientific, industrial, and domestic applications with the available image sensors in today's world. For the product information, please go onto our website www.systemsengineering.in and click onto the Products menu. Under the high-speed camera system without reducing image resolution, one can find the essential features of the product, and below it gives a product manual. Click on the link in front of the brochure for PIV camera to explore features and specifications in detail. Manual describes the imaging system, product, its applicability, unique features with an example, and applications where this product can be used. On pages from page number 2 to 4, please find the selection chart for Omnilert SEPLPIVOIV systems for low to moderate speed products. For a speed range from 180 fps to 1000 fps and resolution ranging from 0.3 MP to 20 MP, please refer page number 5 to 7. Page 8 is dedicated to high-resolution, high-speed cameras ranging from 2.3 MP to 20 MP. For beat and HBDR system, please refer to page number 9, which gives you the highest resolution of 44.7 MP and the maximum speed. Then comes the DART imaging systems for moderate specifications on page number 10 and 11. And then come the specifications for extreme speed imaging systems on page number 12. These are the very special cameras or imaging systems used for scientific studies involving very high-speed imaging applications such as multiphase flow analysis. Obviously, they come with a high cost. The high price is for high expectations.
A digital microscope is a variation or advanced version of a traditional optical microscope that uses optics and a digital camera integrated into it at the eyepiece of microscope. A digital image can be transferred and stored on a computer through software. Scientific cameras are helpful in tracking of combustible matter or particles, analysis of combustible clouds, for mathematical model formulation and source formulation, and its integration at a simulation platform. With the help of different types of camera technology that include 2D imaging, 3D sensing, and infrared sensing, robots are used for several applications. They are the backbones of data gathering and triggering for operations in sequential process, such as arc welding, heavy forging, or general welding, spot welding, hazardous materials handling, machine tending, painting at difficult locations, picking, packing, and palletizing. Online real-time data collection, graphical representation, analysis requires high-speed integrated cameras. The processing of data, its display in real-time mode, and the real-time dynamic or static predictions are possible with increased use of imaging systems integrated into the industrial operations. Some of the cameras are based on gas sensing and can be marked as green or red zones accordingly. We build test rigs for optical instrumentation, multiphase, and combustion studies. We are meant to serve through our innovations in high-speed imaging and computer vision at a pace faster than available. Visualization-based systems, laser-based systems, lighting solutions, precision electro-optomechanical mountings, drivers, goniometers, precision traverses, mounts, optics, and laser-based systems come under our area of focus. R&D is on the next-generation high-speed surveillance cameras, VHS cameras, metro station, computer vision microscopes, film and sports industry, object imaging velocimetry, particle image velocimetry. We supply with our own techniques the advanced laser Doppler systems, phase Doppler system, laser-induced fluorescence instruments, data acquisition and processing systems based on our own frequency slicing techniques, optical ultra-high frequency vibrometer, laser beam scan instruments, RI, measuring apparatus, instrument for surface finish measurements, LD drivers, high-frequency stroboscopes, strobe drivers, LED drivers, goniometers, precision traverses, and the mounts. We supply supporting softwares, LD, PD, PIV, OIV software, computer vision microscopy camera software, and other required interfaces. We also offer unique and best solutions to the aviation industry in an area of the dimmable aircraft windows. To their envy, even the present-day aviation industries don't have such systems fitted into their aircraft assemblies.